Welcome back, everyone. So we're going to move forward on things, but just to get you prepared, I do have the exam scores posted. I've got them ready to hand back so you can see how you did if you haven't already looked. Half of you probably are very satisfied, very happy. The other half maybe not so bad, but I think you all should be proud of yourself that you made it through this first one. If you're not satisfied with your score as it is, that's okay. You will do better as we move forward, I guarantee it. And for the final exam, we will test you again on this material. So I always look at what have you learned by the end of the course. I won't give any details because I make it up as I go, but I'm looking if you can make good progress and you do better on the final than you did on this, you'll find a way to replace this grade with that better score. Oftentimes called a resurrection final. So the final will have parts from everything that we're doing. So everyone still has a chance to get an A. Don't go by the points because that doesn't always say what happened up here in the learning. So we'll work with you. And I apologize for the length of time it took me, but I didn't realize I had 4 exams last week in 4 of my classes, so I've reviewed about 500 exams over the weekend, and I'm a little blurry-eyed. And then this morning I got up to finish up posting everything and made up this and did a few other things, got caught up with my other work. But anyway, I've looked at where we're going, and it will get more understandable as we move away from limits. However, we will also return from time to time to limits. Limits is a tool that we use to understand things. So, but by doing that, we're going to circle back and around. And again, hang on there because understanding happens sometimes like that. That's how I learned. I mean, there would be times where I don't think I'm ever going to get this. 2-3 days later, some epiphany came and it's like, now it all makes sense. And fortunately, I had a professor who also did the same thing, who looked at my grade based upon where I ended up, not necessarily where I was in the first few weeks. So we'll do that, okay? Friday's lecture 2.4, I thought I recorded it. It disappeared. I'll either recreate it or find it somewhere. I might have put it in my trash. I don't know. Anyway, we are recording this one as well. Today we're going to do something called a chain rule. It's because kind of things are connected, so we're looking at it inside of a function. So if you understand composition of function, that's really what this is that we're doing. If you don't understand composition of function, maybe this will help bring that to light as well. So we've got about 3 examples that we'll look over together. Most of this you have to kind of learn by doing. So then we'll get you into time to practice, and then I want to make sure I have at least like 15, maybe even 20 minutes to hand these back. I've got them organized alphabetically. We'll have you come down sort of in that kind of order so we can make the process pretty quick, hopefully. And then if you've got more questions, I've got office hours right after this, and we'll get those addressed and moving forward. So let's see, where are we today? So we're in section 2.5, right where we're supposed to be. Making good progress. And what we're still doing is we're picking up techniques for getting derivatives. And again, what is a derivative? A slope. Slope of the tangent line specifically, or slope at a point, but yes, slope. It's a rate of change at a point on the graph. Okay? So we always have these 2 functions. We have the function that gives us the function value, usually it's location or something like that, and the derivative gives us how that value is changing. And that's one of the key things, and one of the more difficult things to kind of keep track of is when are we talking about the function and when are we talking about the function as a rate. They're interconnected, but we'll get there. Just looking ahead, 2.6 called implicit differentiation. Again, another technique. 2.7, 2.8, we pick up a few more techniques. And then what we're going to do is in chapter 3, we pick up mostly, we go back, we kind of take a step back into algebra and look at exponential and logarithmic functions. How many of you feel comfortable with exponential and logarithmic functions? Or maybe more comfortable than you do with limits? Okay. So we're going to take a dive back into that, and then we're going to look at derivatives of exponentials and logarithms. And then that'll be the stuff. That's all the good stuff for our next exam. And we have actually 3 review days in between, so we'll try to make this as practical as possible as far as working problems, so you can make good progress. Okay, so chain rule. Why do we need a chain rule? Well, sometimes we get a function like this, and so far, the techniques we have, we can do it if we're multiplying, but this would be multiplying 7 times, right? So you'd have to use the product rule 7 times on this. That's a pain. Or you could FOIL it out 7 times, or use the it would be a mess. But with the chain rule, what we're going to do is we're going to see this not as a single function, but as a function within a function. So an outer function and an inner function. That's really what we have to be able to do today. And sometimes that's the hardest part of applying the chain rule, is seeing that we've really got 2 functions, an inside function and an outside function. One of the key characteristics of an inside function, it's got parentheses around it. It's inside the parentheses. Sometimes it's inside of a square root. Sometimes it's in, there's kind of other things that happen, but in this case we see it's inside of parentheses. So what we want to see this as is not as a function, but as 2 functions or parts of functions. So we look at the inside part, which I've got there in red now. That's the inside part. What's the outside function? How would you describe that outside function? Something to the, something to the 7th power, or just x to the 7th power. So it's a very simple function, actually. So that part's going to be easy. And the cool part is we're going just to basically take the derivative of each of those parts and then put them together in the correct way that works. And again, we're not going to focus so much on we're not going to focus at all. We're not even going to talk about the proof. You can read that if you'd like, but we're just going to say it does work, okay? And somebody else did the proof to prove that it works, so we're going to take that result. So the inside function, we'll give it a name, g of x. Why not? Call it whatever you want. The outside function, now notice I've changed variables because they do this thing, they call it u substitution when they go to simplify things. Because if I did it, f of x is x to the 7th, and you've got x being used in 2 different functions, and it gets confusing. But think of u as just kind of, u is that inner function. Okay, we could have called it g. I did that, but a lot of times they're using u for that function that we're going to just say, this big complicated thing, let's just call it u. Okay, and that gets used over and over again. And so we look at this, instead of a single function, we look at it as a function, g of x, inside of an external function, f of x. And then all we need to know is what's the process. We know we're going to probably take the derivative of both of those parts, but how do we put it together? And so we'll look at the formal definition first, we'll talk about it, and then we'll come back to it, and we'll actually do it. Okay. And the nice part about this is it's simpler than the product rule or the quotient rule. I don't know why we don't do the chain rule first, because it's simplistic is its beauty. So what this is saying, and again, you can read all the stuff, but basically, this is and again, it's the German notation from Leibniz. It means exactly the same thing as with prime notation. So it was always the one that confused me, so I try to avoid it if I can. But what this is saying is to notice we're going to take the derivative of the outside function with the inside function just in there. So instead of just u, whatever that is, so we're really just going to take u to the 7th power, take its derivative. It's going to be 7u to the 6th power, right? That's all that's going to happen there. But instead of putting u, we'll put what it actually is, right? And then the second part is we take the derivative of the inside function. And that's the key. That's all there is to it. And so we're going to be able to actually do this as we're able to see it. We're actually just going to be able to write it and be done. We don't have to necessarily put it in pieces and then go. One of the last ones we'll look at has a little bit of complication to it, but it's the chain rule with the product rule. So it's the product rule that makes it difficult. The chain rule, once you get doing it, it's fairly natural. Okay, so the way I put it into words, we're going to take the derivative of the outside function with the inside function unchanged. So we just kind of look at the outside. 7 comes down, minus 1, the 6 is there. That's its derivative. The second part, we multiply that by the derivative of the inside. So we just kind of ignore the outside, just take that inside and put a parenthesis around it so it's multiplying, and we're done. That's it. We don't have to simplify or do anything else with it. And that's the chain rule. But it's also one, again, sometimes if it's very simple functions, it's hard to see that we've actually got two different functions in there. With complicated functions, it's easier, but with simpler ones, sometimes it's hard. So let's take this one. Again, how do we do it? We first recognize that there are two pieces here. There's an inside and then the outside. So first thing is to visualize what's the inside, what's the outside. Maybe write them down so it's clear, and maybe use this U substitution. Again, after a while, maybe even at the beginning, you're able to kind of skip over this and just kind of see how it goes. That's fine too. And just as we've done throughout the course, some of you have taken calculus before, you know other techniques. Some of the techniques I might use, you might know an easier technique for you or a different one. Of course, it's always fine to use any technique as long as you go through and explain it, show it. Okay? And then here's our function. So what we do is, okay, here's our formula to take the derivative of the whole function. It's the derivative of the outside with the inside unchanged times derivative of the outside. So what I'm going to do here is what's the outside function? It's u to the 7th. So, and again, you might not do this all the time, or I just like to do this easy. So the 7 comes down, and then I subtract 1 from the exponent. That's going to make it 6. So actually, I'm going to write that up here, but when I write it, I'm going to replace u with the inside function. So let's write that as this part is just going to be 7 parentheses to the 6th power. Kind of see how that worked. That's all that was. And then it's got the inside part unchanged. X squared plus 3x minus 5. And be careful about copy errors. I saw on the exams, especially on the written part, some copy errors. It was 3 up here and then it was 4 down here, and I figured there was no way that could have happened except just a copy error. I do it all the time myself, so I understand it. But watch for that. So that's the first part, and then we just multiply it by what? Derivative of the inside. Now again, if you've got it written down over here, you can go ahead and do it, but notice how you could actually just kind of focus on the outside. That comes, okay, now I just focus on the inside. So you actually don't have to write down a lot, which actually sometimes is a good strategy, especially if you're like me and you do copy errors. And the more you write things down, the more mistakes you're going to make. So work with your strengths. Some of us, we need to write everything down because, but again, we're each different. And you have to figure out what works best for you. So this is just, and I'm going to do this right under here, 2, this is going to become 2x, right? The exponent comes down first, and then I subtract 1. So that was another issue I saw. Some people were subtracting 1 from the exponent and forgetting to bring it down, or they brought it down after they subtracted 1 from the exponent. Again, that happens, but that's why when we move forward, we'll get better at everything we're doing. This one, the 1 comes down, 1 times 3 is 3, subtract 1, x to the 0 is just 1, derivative of constant is 0. So over here is just 2x plus 3. That is the chain rule. We're done. Not so bad, right? Okay. Again, the hardest part of this is spotting the inside and the outside. Not always so hard, but again, sometimes it's, you got to remember. And when we're in this section, it's usually not so bad. It's when we go to the next ones and we're just doing all this other stuff and we're doing other things, and then all of a sudden a chain rule thing comes up, we forget about the chain rule. We might take the derivative of the outside, but we forget to take the derivative of the inside, or something like that, okay? But that's the beauty of this one. It's nice, it's compact, and we can just kind of do it as we see it with a little bit of practice. Questions? Okay, notice I didn't mess that one. I messed up even with it right in front of my face, I messed up the quotient rule, because I memorized it wrong, and sometimes it's hard to unlearn a wrong way of doing things. Okay, so now, again, as you see, this is one from the homework. I think that you guys might get different ones. If not, just kind of ignore that we've done this together, and when you go to do this one, there's an inside. What's the inside part? What's the outside part? Looks like a little house. That's what I call the little radicals. Everything in here is inside the house. That's the inside part. Okay, so that's going to be like our separate function. And so I'll write it down. Again, you don't have to, but maybe you do it initially. And then what's the outside part? Well, it's the house. It's that radical. So the other function, and again, we don't have to call them f and g, but they just kind of do it, is really just square root of x. Or I guess that's where it's confusing to use x's. So maybe use whatever you like. It's just kind of a technique. Use a smiley face. Some symbol that shows that whatever's on the inside is going to be here. So whatever, f of u. And again, after a while, you don't even write these things down. You just say, okay, there's going to be a 1/2 coming down. It's going to be to the negative 1/2 power, right? And it's got the inside still there. You're just going to write it down. So we're going to take the chain rule. And I like to just kind of, well, it's going to be the derivative of f with the inside unchanged times the insides. So what's the derivative of f? Well, square root of something is going to be 1/2 that inside to the negative 1/2, right? And again, if you want, you go u to the 1/2, right? 1/2 comes down and you subtract 2 over 2. That's why it becomes a negative 1/2. So I can go ahead and write that down. 1/2, what's the inside stuff? 9 plus 6 tan x. That's one thing you're going to see is, tan x. Is you're always going to be able to see that inside part repeated. It's like just stamp it in there. If it's not there, you mess something up. So that's always look for the inside part. It's got to be there. And then it's to the negative 1/2 power. And again, you could put it down in the denominator, put a square root on it, whatever you'd like to do. But, this is good. And then we're going to multiply it by the derivative of the inside stuff. So the derivative of g, right? I like taking the derivative of 9 because it's going to be 0. That's the easy part. Derivative of 6 tangent is going to be 6 times the derivative of tangent. Is anyone... secant squared. Secant, yeah. And again, if you didn't remember, what should you have? Your little card with you. Pull it out. Those are things that you're going to use again and again. And that's why I asked you first, because I knew some of you would remember. And I thought it might be secant squared, but I wasn't sure if my memory was going to be right. So that's where you have that card. And then after you do it a few times, you'll become very confident with it. So that's one of the things is, there's 3 things we need psychologically. One thing is autonomy, so we need to be able to decide, make our own decisions. Second thing is we need to feel competent, that we're smart. And so I find all these techniques to help me feel smarter. And one of the ways is I can double check, and that's the way I feel smarter. But I forgot what the third thing is, but we'll figure that one out. Maybe it'll come. Okay, we'll come back to it. So it's going to be 9 is going to be 0. tangent x, remember the 6 is just is a constant, so we multiply it, and it's going to be secant squared x. That's it. And we just put that over here. And again, other than simplifying, we're done. But maybe make it a little prettier. I can see, okay, I've got this 1/2 up front, and the 6 that can. So I'm going to leave this here, right? So I'm going to put it into a fraction. This is a negative exponent. So let's just drop it down because it looks a little prettier. Nothing wrong with how it was. It was correct, but if you want to do this, and then 2 goes into 6 3 times, and then you've got secant squared x on top, and that's it. Okay, so just a little bit of practice with doing that. I believe WebWorks will accept it either way. I would certainly on an exam accept it either way, so whichever you feel more comfortable with. This is a little nicer to look at. So far, so good. So just find that inside part, take the derivative of the outside part, put the inside part back in, and then take the derivative of the inside part. Okay, so that was 2 examples. Actually, we're going to get done real early. That's okay. Now you see why this one I call the advanced example. Not so much because the chain rule part is hard, is because it's 2 chain rules, isn't it, that are being multiplied. So I got to use also the product rule. So this gives us a chance to bring today's learning back to what we did on Friday. Okay, so yeah, you want to see this. This is really a multiplication. So it's a product rule that has a chain rule inside of it. And so this is where it starts to get a little gnarly, right? It's there's a lot going on. But if we take it step by step and we organize it, we get down which step goes where, we're going to be okay. But be prepared, part of learning is making mistakes and having that willingness to kind of make mistakes and catch your mistakes. And then, because when you catch them, that's where you learn the deepest, Someone else points it out and then you agree with it, that helps too, because sometimes you just can't see your own errors. I know that. But sometimes doing it wrong the first time is sometimes the best thing you could have ever done. Because then when you find out how to correct it, that sticks with you. Okay, so what we're going to do is we're going to break it down because, again, I would do this every time I got the product rule, is I would break it down because it's got all these different pieces going on, right? So what I'm going to do is, let's get some new labels in here, maybe m and n, right? Here we'll just call this function m of x times n of x. Okay, so I've got to use the product rule, and I'm going to do that. And what you'll see is the product rule is going to be the overarching thing because it's sort of the outer thing. And then I'm going to just sort of apply the chain rule as I'm doing the product rule, if it all works out. And I think you'll see, if I do it right and I don't mess myself up too much, that's actually the easier way to do it than to try to throw in too many rules, okay? So the derivative of f of x, right, it's, and actually I'm going to change this a little bit because I noticed the reason I always mess up the quotient rule is when they do the product rule, they do the second factor first, right, without the first one, and then they do the first one and then the second. But in the quotient rule, they switch which one they're taking the derivative of first. So for consistency, why don't we just take the derivative of the first function first? And then we won't have to worry about that quotient rule thing. So I'm going to take the derivative of the first function times the second function unchanged, and then I'm going to add, and this is why it doesn't matter, because with addition you could do it in any order, the derivative of the second function with the first function unchanged. And you'll see if you start doing it this way, the quotient rule follows directly from that. That's really how the quotient rule is done. And again, I'm going, why did they do this? Probably because they don't realize what it's like to live when everything looks backwards. some of us do know what that looks like. Okay. So, and watch, so we've got our functions defined, and we could even put them up here because that's a good way to do it. Now that's the whole function, but for this, just this one piece, how would I take that derivative? Right? Do you see the inside part inside the parentheses? So what's the outside part? That exponent, right? That 8th power. How do I take a derivative of something to the 8th power? The 8 comes down front and multiplies. I subtract 1 from it. Okay? So this 8 is coming down in front. I just copy down what's there. And then I subtract 1 from the exponent. 7. Okay. That's the derivative of the outside part. You see, I'm actually going to apply the chain rule without doing things too obviously. But since I took the derivative of the outside, what do I now need to do? Do the derivative of the inside part, and that's going to get multiplied by it. So you see, that's the application of the chain rule, which is kind of natural, actually. You got to, because, hey, we never dealt with that 5x squared because it's inside, right? It's like in this shelter. So now I can take the derivative of the inside, and it's sort of the same thing. The 2 comes down, right? 2 times 5 gives us 10, and then subtract 1 from the exponent. 2 minus 1 is 1. I'm going to go ahead and put it there. You don't have to, but and then derivative of negative 4, that's a 0 because it's a constant, so it's just, we're done. In fact, I gave myself too much space, but that's okay. That's all there is to it. So I've got that derivative. So notice I'm working on the product rule, which is the bigger thing, but notice how simple that chain rule actually was, as I could visualize it. And sometimes, if it's like on paper, I'd cover it up with my fingers, the inside part, and just say, okay, that's coming down. It works really cool. It helps you to focus on it. And then we just have to do the same thing to the other function, and then we put our pieces together, and then we're done. So it's really not so bad. The chain rule is really one of these things that is, I think it's beautiful. A lot more beautiful than the product rule or the quotient rule. Okay, so there it is. I just copied it down. That's the n of x. That's that second function. Again, kind of cover up the inside stuff. Just bring that 14 down in front, copy what's in there, and then subtract 1 from the exponent. So when we go to take its derivative, 14 comes down, parentheses, 14 minus 1 is 13. And notice I just did that, didn't worry about the inside stuff, and then just put the inside stuff in there. Minus 9x squared plus 9. Am I done? No, because I'm doing the chain rule. Remember, there's always an inside to the chain. That's why they call it chain rule, I guess. But we didn't take the derivative of the inside. So we want to do that, and we'll multiply it here. And again, I realize it's going to be less right now because there's only one term, because the 9 is going to be 0. It's a constant. 2 comes down. 2 times 9 is negative 18, x to the 1 power. We're done. We're done with that part. We're done with the chain rule. That's the new stuff. That's the, wasn't that easier than all that stuff we were trying to do on Friday? Yes. And what we're going to try to do right now is this assemble, right? We've got all these 4 pieces, and now we need to assemble them into the product rule. Mess, but not too bad. So I take the derivative of the m function, that's this part here. So that's I'll write that down first. If you want, you could see, like this 7, you can't get inside this parentheses, but I could, if I wanted, I could take this 8 times 10, or I could leave it. Again, I'm going to leave it up to you to see what works best for you. Sometimes it works good to see all the pieces there. I'll go ahead and write it down, because if I don't, then someone's going, where did that 80 come from? Well, it just took 8 times 10, but you could have done that. So I'll write them down both. So I'm just going to write the pieces down. Minus 4 to the 7th times 10x. Okay, and you'll see, if you want to simplify it, you could write it as 80x. Put that out front. And then we multiply by the in function unchanged, with nothing done to it, without its derivative being taken, and that's right here. So we just copy this part down, and again, it's multiplied. We don't even need to have a symbol. We just write them side by side. And then we've got this plus. So that's always the key part. Sometimes when you get all your stuff together, two of the things are being multiplied, we got a plus over here. And again, we just take our in function, which is right here. Probably should have gone down a little lower. That's always my problem, is planning ahead and giving myself enough room. But again, we just write this down, 14 minus 9x squared plus 9 raised to the 13. I'm going to erase it. I need my negative 18x, but I need space. So let's give myself some space since I didn't give it to it. Negative 18x. But I'm not done yet, am I? I need the first function that has not had anything done to it. That's this. Okay, and since this is being recorded, you can always go back to it, but let me just get that out of the way. And then I'm going to have 5x squared minus 4 to the 8th. Okay, and then what's a good thing to do is go back through it and see if the structure makes sense, right? So when you take the derivative of something to a power, it should be 1 less. So I see that first one is 7. Up in the original, it was 8, so that makes sense. And I see the 8 came down. I see the second part. Right here is unchanged. That's good. I see I've got the derivative of the inside part. Okay, I'm feeling good. I look to the second part. I see that up here it was 14. I see the 14 came down, and then it became 13 in the exponent. That's looking good. This inside looks like it's the derivative of the inside part. Yep, so I did the chain rule. And then I got this other piece, the first one unchanged, from the product rule. Okay, so it's, again, have that product rule there, that formatting, and then just do a double check, because it's so easy to leave off a piece. Sometimes you had it here, but not copying it or something. And then if you got to use it later on, and you left off a piece, all your answers from there are going to not be quite right. And again, you can take this 14 times the 18. You can simplify as you like, or you could leave it, because by leaving it, all our evidence is there. And I feel more confident right now because I got that. I see that 14. Okay, I remembered I did every piece. I'm just going to leave it. Because if I need to get the value of that rate of change, I could just plug in an x value, calculate it, right? I can put it in a calculator, do it. Doesn't matter how pretty it looks, it's going to give me my output value. But I have the ability to get that derivative now. I mean, I have the derivative. It doesn't really matter whether it's simplified or not. In fact, I find by not simplifying, I feel better about it, and I understand it more because I see all the pieces. As soon as you start simplifying things, you lose evidence of what happened. You see an 80. Where's 80 come from? I don't see any 80 up there. But I do see the 8, and I see a 10x. I see where those pieces came from. Mathematically, that's so much more important than simplifying. Yep, culturally within the math world, it's like, well, if you can simplify it, let's do that because it'll make it look different. Additionally, at least it's my opinion, that in mathematics has a strong feeling that they actually don't want people to learn it, right? Because math is power. If you're the one that can predict when the eclipse is coming, you got power over everybody. You don't want everyone else to have that. That's the culture of math. It's a hidden science. They really didn't want everyone to learn. And so there's a lot easier ways to do it. Let's try to make it so we can all learn it. Okay. So anyway, that's the product rule, or the chain rule with the product rule. Okay. Is that good? Right? So and that's what we're going to do is even when we get into Wednesdays, implicit differentiation, it's just sort of another technique. We're actually going to take derivatives of two variables at once, but it's not going to be any more difficult than what we've been doing so far. Okay? But there will be some sort of patterns that we have to follow. So that's the other part that I really liked once I started understanding calculus, is what it does for your brain. Thinking of, if you want to build your body, you go to the gym and you do stuff like this to build up this muscle, not because you're going to be doing this all day, but you're doing different things. Math, it's not the fact that you're going to be taking derivatives and doing all this stuff for your career or anything, but you'll start to see connections with how things are organized. When you get in a problem situation, you're going to be a better problem solver because you're going to see the patterns of the causes for what causes problem. Because that's the important thing. If you try to fix something but you don't know what caused it, it's just going to happen again, right? So, but if you can see these things, it's how it inspires you to become a better problem solver in your life, and whether it's dealing with numbers or emotions or anything else, you will become better at it because you will see the patterns. You'll see your own patterns. All right. I've delayed enough because I didn't want to get out too early, but I do want us to get going. So chain rule, so it's a composition of functions. It's a function within a function. So the main thing we need to do is we need to see the inside and the outside pieces. And then derivative of the outside with the inside unchanged. You see it right in there, times the derivative of the inside. That's all there is to the chain rule. But again, we're going to be applying it in various ways. We're going to be applying it with the product rule, with the quotient rule. It's an overlying thing. So keep working on questions, 18 questions in 2.4. We got 20 questions in 2.5. And now, before you start taking off, today is the last day you'll be able to pick up your exams in class. After today, they'll be in my office, and you'll have to follow me to office hours if you want to pick it up after today. So, but those who want to pick up, okay, just sort of the results. Okay, we did have 50% of the class achieve an 80% or above. Without it, that's just how it was. Can I have your attention for just a few minutes, and then then you can kind of go or whatever. It's going to get noisy, I know, but okay, 22%. Pretty much got 100%. I went down to 98 because they missed a little calculation error, but you understood perfectly. 33% were between 78 to 97. I realize at least 50% of you who did below the 80%, but again, it's a start. That's where I was. Look at me now. I'm teaching. So keep moving forward. So we're going to start. If your last name starts with H through N, I've got your papers here. You come down. What I've got a spreadsheet with names and numbers. If you could give me your number, I've got them in order here, and then check off your name. So H through N to start with. We'll do the rest of the alphabet after we get these done. Let's see. So find your name and tell me your number. 49, awesome. 64. 56.
76.
$57.
Where do we keep them?
And you may keep them. Yes, they're yours.
66.
66. 59. Oh, there you are. Jumped right to you. Thank you. Yes. Any more for A through N? And if by your last name, I think you're right. Yeah, I went by the. Okay, I'm switching to 8. A through N. Oh, that's perfect. All right. A through G. Just give me the number and I'll find 7.
Is there anything to do in this grade or just next time?
Keep going forward and improve.
33.
What'd you get? No way.
15.
15.
Wow. Oh my.
45 and 38.
70. No, it's not. Oh yeah, definitely need to study. If I had to wait until my last name was Vanessa, so all the way to the last digits. 13, 42. I did some. The exam one.
23.
Did you get the 20 points? 24 points off?
Feel like we're at an auction here.
I'm pretty sure. If you tell them about it, be like, yo, tell me what this is. Say I review that. Here's this goes. So 20 assessment, type review. Yeah, you probably have to change it.
Where I wish I had pre.
You probably just hold it for an hour and like that.
I don't know if they still are though. Yeah,
That's low key kind of.
Yeah, that is.
18.
You said like scan a QR code, fill a survey.
Oh. Right. 52 on the other.
Have to do better. Wait, so you.
All right. O to Z. We get you this time? Yep. Okay. Just a moment.
106.
6.
Thank you very much.
10. 88.
I actually had a question. In the grade book, it showed it was a 0. So I was just wondering what the fix that. Because I wasn't sure.
Let's find out. That's one that's.
What did we leave this one
I
on?
didn't have the exam.
Right.
Yeah. It's yours. You keep it. 89. 98.
What's her name?
Also, how is that?
Because I do that, I do it so that every point is the same. So homework, 1 point on homework is 1 point on the test. So it's a whole system. Yeah, so it's out of a total of 1,000 points.
99.
Is that which number? 83. Which number? 92. 92. Okay.
111.
I don't know.
There's that one.
I'm P, but I'm PA.
Do you have more than one?
I have, I'm at ENG.
Yeah.
Yeah, I am. 36.
Okay.
Yeah, I didn't know that.
What do you want? We've been waiting for you. Thank you.
So on the test, I know that on the back here I put this for number 7, but I originally had it as that. I had to ask someone what like made me change it to the back of the A. Like, is there any way like I know there's no way to verify it, but I know. It's because I went through this out part first, but I don't know where I actually messed up and like.
Send me an email. Say I talked to your class.
Okay, sounds good. All right, thank you.
Send me, I say the work there. Organism some thousands, and it should have been 30,000. Send me an email, say number 4.
You're better off.
This part here, it should be 196 square.
This is just the answer. This is for this one. This is for the one. Yeah. So this is
Okay, well, I saw this one. Send me an email with the canvas or whatever, because I have the name on it. Say reference number 234. Say respect. Yeah, follow me and send me an email with your name.
Okay, thank you. I have my scratch.
Well, you wouldn't. Yeah. There's a few other people who didn't take that practice putting that there. But we need to locate it. It's possible, hopefully, put it in. Check my office, check it, could, it was the one that maybe fell out somewhere.
I can email you.
Email you can your name, but I mean, when I find this one, we'll locate it. She's gotta do a makeup test. Going forward, and as you do better, especially by the time the exam is, I can take a look at your score.